Evening all. Let's have a go at this question. Normal distribution. Causing problems. The heights of a population of women are normally distributed with mean, that says mu, the Greek letter, centimetres, and standard deviation, sigma, centimetres. It is known that 30% of the women are taller than 172 centimetres and 5% are shorter than 154. Sketch a diagram to show the distribution of heights represented by this information. There are 3 marks available. You see it there. So I'm going to draw a normal curve like that. There's my curve. Doesn't have to be perfect. The important thing is it doesn't cross my axis there. It should be symmetrical. It's not a great drawing, but I get the 3 marks. Okay, it's going to look like that. Now I get 1 mark for doing the bell curve. There's 1 mark. Second mark is for putting in 172 and 154. This area here, less than 154, says 5% are shorter than 154, so I label that 5%, and I've done a bit of it. Same thing here, apart from actually I'm just going to move this. I'm going to make that a little bit of a better drawing. Okay, and I'm going to put my 172 there. Okay, there it is, straight line, should be a straight line. Okay, now at 172, this area needs to be, it says here, 30% of the women are taller than 172. Okay, so sketch a diagram to show the distribution of heights. I get my second mark, there we are, second mark for putting 154 on 172, and I get my third mark for putting 5% and 30%. Job done, tick it off. Next thing says, show that the mean is equal to 154 plus 1.6449 sigma. So we've got the 154 in the question already. The problem is 1.6449. Okay, in the question, as soon as I see exact probabilities, exact percentages, so it says 30% and 5%, as soon as I see that, I'm going to go to table 2. Table 2 in the formula booklet, and that comes up here. So underneath, sorry if you can't see this too well, I'm going to draw another bell curve, and this is so I can use my Z table. Sorry about that, I'm really not very good at drawing these, but it does the trick. Remember, symmetrical, there it is. Remember, the question said show that. Got it? There it is. So I'm going to use 154. 154, which is here. So I need to know what this point is there, what this point is on the Z table. So I do Z equals x minus the mean divided by the standard deviation. So Z, which I'm going to have to look up, is x. X is 154 minus the mean divided by the standard deviation. There it is, 154 minus the mean divided by the standard deviation, which is similar to that. Now, I know that at this point 5% are to the left. So I go to my table, here it is, I've got it on my computer, and I see that probability right there. That means 5%, 0.05. So that's 5%, and the Z value is 1.6449. Let's come back. We know that this Z value, when that happens, is 1.6449. Now this is going to be 0, because this is the Z normal curve with mean of 0, standard deviation of 1. Okay? So if that's 0, anything that way is negative, and anything this way is positive, so that must be negative. So instead of Z over here, I write minus 1.6449 equals 154 minus the mean divided by the standard deviation. Rearranging, 154 minus the mean equals 1. I'm just going to bring the standard deviation up here, so 1.6449 times by the standard deviation, and you should be able to see at that point that you can easily rearrange. So this mean is negative, so I add it to the other side, There it is. Okay, and this is negative, this minus 1.6449 sigma. So I take that to the other side, it becomes positive, and I get 154 plus 1.6449 sigma, and that is what I had to show. 3 marks. We'll stop there, we'll come to those 7 marks in a second. I hope that helped.